Hello everyone, I am Nagendra Krishnapura from the Department of Electrical Engineering at IIT Madras. I will be the instructor for the course Analog Circuits. In this short video, I am going to tell you what is going to be in this course. The course is titled Analog Circuits. So, what are analog circuits? Analog circuits are nothing but circuits that process analog signals. Now, what are analog signals? Analog signals are normally thought of as what you see in the top left here, signals that vary continuously in time and also have continuous values of voltage or current or any other quantity. Okay. Now, what are the other types of signals? You could have continuous values of the signal, but signal changes occur only at discrete instants of time, such as what is given here. This is known as sampled analog or sampled data analog, or you could have only discrete values, but the changes could happen at any instant. This is known as continuous time digital. And finally, you could have discrete values in x and y directions, that is signal changes occur at discrete instants of time and they take on discrete values. Discretization is shown by these ticks on the x and y axis here. This is known as digital, and the most familiar form of digital that you would know is when there are only two possible values, and that is a binary digital signal. Now, the signal classification is likely to be already familiar to you, and like I said, the circuits that we will deal with handle this type of signals or analog signals. But this is a sort of confusing definition, not very useful, okay, because you would have already learned circuits using resistors, capacitors and inductors, and they also handle signals like this. They operate in continuous time and they have signals which have continuous values. Okay. So, when we say analog circuits, it is normally understood that we are talking about amplifiers or active devices, which are distinct from the passive devices which you would have learnt in a basic circuits course, that is circuits using elements like resistors, capacitors and inductors. So, unlike them, we will have amplifiers, which are ways of realizing control sources, which again you would be familiar with as a model, but you would not know how to build them. Okay. So, although we say analog circuits and they handle analog signals, normally when we have a course such as analog circuits, what you would be learning is how to realize amplifiers and analysis of amplifiers and so on. Okay. Now, in this day and age where we are surrounded by gadgets, these amplifier devices are absolutely everywhere. As an example, I am showing a teardown of a mobile phone which is taken from the web, and you see blocks such as audio, D to A converters, A to D converters, RF and power and so on, and you even see something labeled as amplifiers. Now, all these have amplifiers, and interestingly you would know that digital circuits play a very important role, and in order to realize digital logic gates you need to have amplifiers. Okay. You do not use them like analog circuits, but if you did not have amplification you could not have all the good digital circuits that we have today. Okay. So, for now just take it from me that amplifiers are absolutely everywhere around us. Okay. So, what is this course all about? It is, like I said, about amplifier devices and circuits. You can make amplifiers with a variety of devices, but the device that is most predominant today is the MOS transistor, and that is what we are going to use. We will also introduce the bipolar transistor, which was earlier dominant, but the principles that we show here about how to bias amplifiers, how to use amplifiers, how to apply signals to amplifiers and so on, these will be applicable regardless of what device you use. If you want, you can go back 100 years and start to use vacuum tubes, or in the future some other device will be invented and you can use them. So, the principles will be applicable to all of them. Okay. This course will be a prerequisite to any electronic design course. The electronic design course could be about IC design or some other electronic system design on a board or power electronics or any such thing. Okay. So, all of them use the principles you learn in this course. So, the course structure, the course will be 8 weeks long, but I will also include 3 weeks of supplementary material. The certification and evaluation will be based only on the first 8 weeks. Okay. Details of the syllabus and structure of the course will be available on the website, so you can go through them. The course goals are for you to understand basic amplifier topologies, calculations involving amplifiers, and also more importantly how the topologies come about, so that tomorrow if you have a new device you can try to synthesize your own topologies using those devices, and biasing principles for any particular device. Okay. In order to take this course, you need to have some prerequisites. You need to be fluent with circuit analysis, that is mesh and nodal analysis, and circuits with linear elements such as RLC and linear control sources. And you also need to be somewhat familiar with Laplace transforms and frequency response. And of course, you need to know basic calculus and differential equations. Okay. So, that is the short introduction to this course. The resources available to you for this course as well as for the prerequisites will all be listed on the web. Okay. Enjoy.